Hello, hello. It's time for Trig. Today we'll cover more of the solving and algebra stuff, and in part 2 we'll cover the graphing part of it. So, the biggest new thing that we discovered or added in our toolbox was radians. It's just another way of writing angle measures. So instead of degrees, which is honestly weird if you think about it, like where did 360 even come from? Instead of that, we're using radians. Sorry about the bad graph. All radians is, well, you know the unit circle, right? What's special about the unit circle? Your radius is 1. What's the circumference of a circle? It's 2 pi r, but the r is 1, so it just cancels out. So it's just writing it in terms of radiuses, how many radiuses around. If the radius is 1, well, that's 2 pi radiuses around, and that's what radians are. You don't need to get too deep into that. Just know 360 is 2 pi. That means 180 is pi, 90 is pi by 2. And then we can figure out the rest of the angles. Oh, ignore this. We can figure out the rest of the angles using, well, by just using fractions. Okay, some special angles that we looked at in grade 11 were 30, 45, 60, 90, 0. Okay, and a way to memorize or just a easy way or shortcut to memorize them is the denominator is what's gonna help you figure out what degree yeah what angle it really is. The 4 and the 4 stays the same, so 45 is pi by 4. With the 30 and 60, this 3 turns into a 6, the 6 turns into a 3, so pi by 3 is 60, pi by 6 is 30. Okay, 0 is just 0, 90 is half of 180, so pi. And then with conversions, I don't think there'll be any question on the exam about conversions, but still, you know the ratio, pi is 180, so you just use that. If you have degrees, let's say 315 degrees, you multiply that by pi over 180 because you're trying to keep the pi. You're trying to convert it into pi, so the pi goes on top, and you're going to get 3 pi by over 4 after simplifying. And if you're doing it the other way, 3 pi over 4, now you're trying to cancel out the pi, so it goes on bottom. And now your answer will be in degrees, and that's going to be 315 degrees. So it's pretty easy. And moving on to the table from grade 11 again, you remember how to do this: 0, 1, 1, 0. Then you go 1, 2, 3, 3, 2, 1. Square root all of them. Square root of 1 is just 1, so I won't bother. And then divide everything by 2. Everything. And with tan, it's just sine divided by cos. So 0 divided by 1 is 0. 1 divided by 0 is undefined. Same numbers divided is 1. 1 half divided by 3 over 2. 1 half divided by 3 over 2. Same thing as 1 half times 2 over root 3. 2 cancel, we're left with 1 over root 3. And this is just that same interaction flipped. So instead of 1 over root 3, we get root 3. Okay, so these are your basic values, except now instead of degrees, we're using radians. So sine of pi by 6 is half, 1 half. Instead of sine of 30 is 1 half. Same thing. And with the unit circle, remember the radius is 1. So if you stretch a line like that, remember from grade 11, we also looked at this. What is sine? So S equals opposite over hypotenuse. Well, my radius is my hypotenuse, and that is just 1, so it just cancels out. So my sine is my opposite, and what's my opposite? That's my y value, how much high this point is. So any point is going to be cos, because that's your x, the adjacent, time, comma your sine. Okay, your x is your cos, your sine is your y. So that's for unit circle questions. And then we have some new functions that we learned: cosecant, secant, and cotangent. Cosecant is the reciprocal of sine. Secant is cosine flipped, and cotangent, it's in the name, it's tan flipped. So Cos is the flip of sine. S secant. S cos. Just memorize it. It's pretty easy. Okay. So now to the kind of difficult part, the new part. Solving basic functions. So for these type of questions, okay, remember how you used to solve these type of questions? Cos of, let's say, 315. You used to see, oh, this is between 270 and 360. So to find the reference angle, you would do 360 minus 315, 45, and you would see, oh, it's in quadrant 4, cast rule, this and that. It's the same exact thing all over again. Okay, a trick I like to use, just get rid of the pi and just look at the numbers. This is 0, this is a half, which is zero point 0.5, this is 1, this is 3 over 2, 3 pi over 2, so this is 1.5, then a full circle is 2. So where does 7 over 4 land? Well, 1.5 would be 6 over 4, so it's above 7 over above 1.5 and below 2. So my line is going to be right here. And to figure out the reference angle with radians, this is the one thing that's actually pretty easy. You just look at the denominator. Like I said, the denominator is what defines it. You know it's 45 degrees. You know it's root 2 over 2. So you know it's root 2 over 2. And now don't forget the cast rule. C A S T. So quadrant 4, cos is positive. So our answer is positive root 2 over 2. Okay. Now with the other case scenario, when you're trying to find the angle, okay, again, same thing applies. You see which theta equals your positive value. So which theta equals 1 over 2. If you look at your table, sine of pi by 6, which is 30 degrees, pi by 6, okay, that's your reference angle. And now you do the cast rule again, cast, and you see, okay, sine is negative in quadrant 3 and 4. So your lines look like this and this. So you're in quadrant 3 and 4. In quadrant 3, my answer is pi plus. So pi plus pi over 6. Okay. With a little bit of solving, this becomes 6 pi over 6 plus pi over 6, which is 7 pi over 6. And my other one is 2 pi minus pi over 6. Okay. 2 pi and then go, oh, 2 pi and then go back pi over 6. So that becomes 12 pi minus pi over 6, which is 11 pi over 6. So those are my two answers, or are they? Well, that's that's where it gets a little weird with intervals. So this would be my answer if my interval was 0 theta 2 pi. If my theta is between 0 and 2 pi. Why? Because let's just take this arm, for example, this angle. Okay? This angle. So currently we're talking about this angle. But what if I add a rotation and another rotation? Okay? Or what if I'm trying to go in the opposite direction? That's called coterminal angles. Okay? Coterminal angles. If you add, did this in grid 11 too. You just add 360, add a full rotation. In this case, it's 2 pi. If you add a 2 pi, if you add a 2 pi to this one, okay, the angle, the arm stays the same. You just go another rotation around. What if you add another 2 pi, another rotation, okay, and it keeps going till infinity, right? You can just keep adding 2 pi's. And now, what if I'm trying to go into in the other direction? Instead of going here and adding a rotation, I subtract a rotation. So technically, I'm going this way. Instead of going that, I'm doing this way. So I could also write it as 7 pi over 6 minus 2 pi. Okay, and then I could go another rotation in the opposite direction, minus 2, another 2 pi. Okay, so that all depends on the interval that they gave you. But if the interval is infinity, then you have to use something called general form. General form is very easy. You don't need to overcomplicate it, no matter what your teacher has told you. All you do, take your answers, add a 2 pi k, and say that k has to be an integer. Because we're saying integers because it also covers all the negative values. Okay? So that's why we only write a plus here, not a plus and minus. Okay? So that's all you do. Just plus 2 pi k kei. Okay? And that's it. Now moving on to the fun part, the solving part. So this is the formula sheet that the province gives to you on the exam. And this I haven't seen on any exams, but I'll just go over it. S is arc length. Okay, theta is your what do you call it? Angle, and R is your radius. So arc length, radius, arc length, theta. So I guess it's just the ratio between your arc, the relationship between your arc radius and theta. Right now, their radius is 1, so you can see that your arc is equal to your radius. Like remember, I said the circumference is equal to your angle. I guess that's kind of the relationship. I'll put a question about that that you can try solving. It's pretty easy. Don't overthink it. Just plug in the formula, go with your day. And now come the actual identities. So these are just formulas. Okay, it's not as hard as you think. Wherever you see a sine square and a cos square, it's 1. This is your favorite identity in Miss Joll's words, and these are variations on that. Okay, you do some algebra and you can find them yourself. If there's theta, if there's two numbers that are being added instead of the theta like that or subtracted, then it's one of these identities, and these are the easiest ones to see because it's literally in the question. It's gonna look exactly like this. And coming to the results, if your question gives you something like that, like you'll see it pretty easily. Then come this two theta ones, and honestly guys, it's just looking at the question and looking at your formula sheet and seeing which identity works. And if you pick an identity, you use it, you're gonna get to the right answer. Okay, so I didn't really know how to go over this, so I'm just going over every single type of question that I could find. And all of these questions are going to be like, pause, do it yourself, and then try to follow along with my answer if you don't get it. Okay, so the first type of question that you can see a lot of is proving. So with proving, like I said, just look at the question. Your first thought should always be, is there an identity that I can use? Okay, so if not, simplify it. Think again, is there an identity I can use? If not, then write, if there's a tan or a secant or a reciprocal function, then you write it as a sine or cos. Then you look back at it. Is there an identity I can use? Okay. Then if even if that doesn't work, okay, in the last case scenario, if your answer has something like this, 1 plus like something sine divided by 1 plus cos, something that's 1 minus cos, or like 1 plus something or 1 minus something, okay? Conjugate means you're multiplying it by 1 minus the same thing, okay? Because remember, difference of squares. So the bottom becomes a difference of squares. Like if say this is sine. Also remember, multiply both top and bottom. So you just flip the sign and multiply the same exact thing, and the bottom becomes a difference of squares, cos squared, and the top becomes whatever, sine 1 minus cos. Okay, but why we do this is usually because we can use the first identity. If you arrange it differently, you can see that sine squared equals 1 minus cos squared, and that's right here. So this turns into a sine squared, and then sine 1 minus cos, and you can cancel it. So it becomes 1 minus cos over sine. So conjugate, wherever you see a 1 plus 1 minus, it should be your last option, because sometimes you can just solve it without using conjugate. But if you really can't think of anything else, just and you see that like 1 plus something, 1 minus something, just conjugate it. You'll see what I mean. So first question. Cosecant squared x times 1 minus cos squared x equals 1. Try it yourself. Pause the video and then look at this. Okay. So first of all, we divide our question into LHAs and RHAs. Okay. Now, first thing I see, is there an identity I can use? Well, yes, there is. I see it right away. 1 minus cos square x, my favorite identity. We just talked about it. Okay. So my left side becomes cosecant square x, and I like working with just one side at a time. I just like to keep the other side as it is. Sometimes I'll work on it, but usually not. Next step, do I see another identity? No, I don't. Can I simplify it anyway? Not really. What I can do is write this in terms of sine. So cosecant, remember, cosecant is the reciprocal of sine. So I can write this as 1 over sine squared x times sine squared x. And well, they just cancel out. So I'm left with 1. And this is equal. Remember, all your proving questions, always end them with LHS equals RHS. Okay, and that's proved. Next question, tan x minus 1 squared equals secant squared minus 2 tan x. Again, try it yourself, then follow along. So LHS, RHS. First thing I see, is there identity I can use? Is there identity I can use? I don't think I don't see any. So what do I do? I simplify. What can I simplify? Well, I can open up this bracket. Let's see if that helps. So this becomes tan squared x plus minus 2 tan x minus plus 1. Now and this just says as secant square x minus 2 tan x. Now I see. Is there any identities I can use? Well, also look at your answer, look at your question for clues. I see that minus 2 tan x and minus 2 tan x is the same. So I'm trying to make this tan square x plus 1 equals secant square x. Well, if you look, that's an exact identity. So you can take the help of your actual answer in that way. Just use logic wherever you can and trust yourself, okay? So we can see that this plus this is an identity. So well, it just becomes secant square x minus 2 tan x. This is equal. And what do we write? LHS equals RHS. Okay. Moving on to the next question. Secant x plus tan x equals cos over 1 minus sine x. So pause, try it yourself, then follow along. LHS, RHS. Well, without looking at anything, I can already see a 1 minus sine x as a conjugate, but I'll just leave it for now. Let's try the other stuff. So can I see, do I see identity? I do not. X, sorry. Can I simplify anything? Not really. Can I write anything as sine and cos? Yes, I can. So secant becomes 1 over cos x plus tan x becomes sine x over cos x. Okay, this becomes cos x. This just says 1 minus sine x. I won't do anything to it right now. And now can I simplify anything? Yeah, I can bring these together. 1 plus sine x over cos x. Now there's nothing else I can do. And I see a 1 minus sine x, 1 plus sine x here. So now I'm thinking conjugates. Doesn't matter which side you do it to. Just to keep it clean, I'll do it to this side. 1 plus sine x. Okay, just flip the sign and whatever it is, keep everything else the same and multiply this on both sides. And it becomes cos 1 plus sine x over 1 square minus sine square x. Now, do I see identity? Yes, I do. It's my favorite identity. Well, now it's sine instead of cos, but you know what I mean. So this becomes cos squared x. Oh, also don't forget to write your x and thetas. Very important. You'll get marks docked. And so what's left is 1 minus sine x over cos x, 1 plus sine x. This is equal. LHS equals, 1 divided by LHS equals RHS. Next one. Try it yourself. Then, oh, okay. LHS, RHS. Okay. So now the one time you kind of have to think about using identities is with cos 2 theta and cos 2 theta only. Because if you look, cos 2 theta is the only one that has different possibilities that it could be. Three different to be specific, but it's pretty easy. You're just, honestly, you would probably never use this one, like the cos square minus sine square. You might, okay, so don't quote me on this, but usually it's gonna be either this or this. And how you use it is, well, if your question or your answer is asking for a sine, okay, if it's or if it's asking for a cos, just look at your question, which one would suit better, and trust me, it's way easier than you think, and yeah, you'll get it. So in this question, well, the first thing I'm trying to do is, can I simplify this? 1 minus tan square, is that an identity? 1 minus tan square is not, but what is 1 plus tan squared, right? And that's secant squared. So I can write that down. So it becomes 1 minus tan squared theta over secant squared theta equals cos 2 theta. Okay. Now, is there anything I can do? I can't simplify anything. Identity. What I can do is write it in terms of sine or cos. So this becomes 1 minus sine squared theta over cos squared theta over 1 over cos squared theta. Okay. So now what I can do is I can take this and I can simplify even more. So there's two ways you can do this. Okay. You can either multiply this first, or you can use the one and do it. What I'm gonna do it this way. I'm gonna take this and simplify it like this. My 1 minus sine square theta over cos squared theta, and I'm multiplying this by I'm dividing it by 1 over cos square, so technically I'm multiplying by cos squared theta. So give this to both of them, you get this gets cancelled and this turns into cos squared. So it becomes cos squared theta minus sine squared theta. And it's kind of ironic. I just talked about how you're not going to use it much, and it comes up. But yeah, so you see cos squared theta minus sine squared theta is cos 2 theta. And how I knew that's going to be right, because I took the hint from the question too. It's going to be equal to cos 2 theta. And so that means we did it right. So LHS equals RHS. Now, when you paused it and did it, maybe you did it a different way. Maybe you did it the way we did it in our notes. You can look at our notes and find this question there too. But sorry, whichever way you did it, as long as you get this LHS equal RHS, that's honestly all that matters. Okay, next question. Sorry. 2 over 1 plus sine cos 2 x equals secant square x. Okay, so let's do the same thing here. LHS over RHS. 2 over 1 plus cos 2x, and this is secant square x. Okay, looking at my left side, the first thing I'm trying to do is add an identity. So I see cos 2x. I see cos 2x, and I know I have three possibilities. Okay, I can either turn it into cos square minus sine square, 1 minus 2 sine square, or 2 cos square minus 1. And like I said, it's better to choose between one of these two. Only do this when you have to. And looking at my other side, okay, the other point that I talked about, take the hint from the question itself. Look at my other side. It's secant squared x, which is 1 over cos square x. So that kind of gives me the hint that I'm trying to go for cos. And so let's just use the cos equation. Cos 2a is equals to 2 cos square a minus 1. Let's just use that. So 2 over 1 plus 2 cos square x minus 1. Okay. And now what do we see? The 1 and 1 cancel out. We're left with 2 over 2 cos square x. The 2 and 2 cancel out. Voila. It's that easy. Okay. Just find the right, just chug identities wherever you can. Simplify, turn it into sine or cos, conjugate if you need to, and you know that they won't give you a wrong answer. You're not proving them wrong. You're always proving they're right. So whatever your RHS is, it has to equal that. So take it as a hint. Okay. If it's cos, make it cos. Okay. Take your other what do you call other sides as a hint of what you're trying to get. Okay. Then the next type of questions are your weird angle questions. So we know our special angles, the pi by 3, 4, okay, this and that. But sometimes your questions will have weird angles, pi by 12, and there's two possibilities that happens. Either it's just a straight up identity, as you can see, wherever you see two sines and two coses in any order, always think sine a minus b or sine a plus b. So right now, what was our question? It was cos minus sine. Which one is cos minus sine? Cos. Oh, this is plus. Cos minus sine is cos a plus b. Okay. So this is cos a plus b. Our a is pi by 12. Our b is 5 pi by 12. Okay. So just plug and chug. This becomes 6 pi by 12. Okay, 6 and 12 cancel. The numbers will cancel. And it's going to become an angle that you already know. Pi by 2, that is 90. Cos of 90 is 0. Okay? Now, This is the harder version of the question ish. Is, I guess, not harder, longer. Now, instead of having a straight up identity, we just have that angle. Now, normally, we would just solve it like that using this as our a reference angle. But we don't know pi over 12. We don't know that as its like as a value. So what we do is we use our identities, our plus and minus identities, to our favor. We line up all the angles that we know: pi over 2, pi over 3, pi over 4, pi over 6, pi over, or well, that's all, I guess. Right? What else do we know? I guess just pi. And now we make them, turn them all into the same denominator, pi over 12. So it becomes 6 pi by 12. It becomes, what do you call it? 4 pi by 3, 3 pi by 4, 2 pi by 6, and 12 pi. Okay? By 12. And now all we're trying to do is find two of these that either add to 7 pi by 12 or subtract to 7 pi by 12. Do you see where I'm going with this? So, as oh wait, these are 12, sorry. Okay, as you can see, these two numbers perfectly add to 7. Okay, so cos 7 pi by 12 is also equal to cos of 4 pi by 12 plus 3 pi by 12. And what are these actually? Well, they are pi by 3 plus pi by 4. And well, now it's just an identity. Now we've converted it into numbers that we already know. So the identity we use is the same one we just did, which is cos cos minus sine sine. So that's going to be cos pi by 3 times cos pi by 4 minus, it is minus, right? Minus sine sine. Minus sine pi by 3 sine pi by 4. So cos pi by 3, go back to our table. What is cos pi by 3? Cos pi by 3 is 1 over 2. Okay, so we use that. That's why it's important. Just whenever you get the exam, just make this table. So you don't even have to worry about memorization. Just do the little tick, make the table. Okay, 3 is 3 is 60 degrees. Okay, times root 2 by 2. And then minus root 3 by 2 times 1 root 2 by 2. So that becomes root 2 over 4 minus root 6 over 4. Or well, if you take the common denominator, it just becomes root 2 minus root 6 over 4. Okay, that's how you figure out numbers that angles that you don't really know. You turn them into angles that you already know, or it's gonna be in like a straight up identity form. That's super easy. The third type of question is they give you a cos value, they give you a sine value over a certain interval, and you have to find the value of a certain identity. Okay, now this with this one, all you got to do is make triangles. So cos A equals negative 4 over 5. Well, what is cos? So ka to. Okay, so this triangle, this is your adjacent, this is your hypotenuse. So in your graph, and you see it's between pi by 2 and pi. Okay, it's in this interval. So is your triangle is gonna look like this: negative 4, the hypotenuse is 5. And now using that information, you can find out what your uh, opposite is. Okay, so my opposite is gonna be 5 square minus 4 square rooted, right? Pythagoras. 25 minus 16 is 9. 9 rooted is 3. And since it's in this quadrant, it's positive, as you can see. And for the other one, same thing. You just make its own triangle. It's between pi and 3 pi over 2, so this quadrant. And now your triangle looks like this. Oh, 13. And your sine, which is the opposite, so this is negative 12. Okay, so you to find this angle, it's 13 squared, not angle, side. 169 minus 144, that's 25. So this is 5, right? Let me write that. Yeah. So this is 5, and now we have the missing values. Now that we have the triangle, we just plug this identity in. What is cos A minus B? Well, cos A minus B is cos A cos plus sine sine. Cos A cos B plus sine A sine B. Well, cos A we already know, negative 4 over 5. Cos B we did not know, but now we can find it because we found the adjacent, right? So cos B is just 5 over 13. Oh, sorry. This is supposed to be negative 5 because of the quadrant, right? You're right. You're right. And then plus sine A we didn't know, but we found 3 over 5. And cos A is, I mean, sine B is negative 12 over 13. And now you can just simplify it. I'm too lazy to do it, okay? But this is how you do these type of questions. The fourth type of question is, this is a unit 4 question. This is the basic one. So solving one function and okay, so this is when you're solving and there's only one function, one type of function, and you have a normal theta. Your theta isn't being divided or multiplied by anything, okay? It can your function can be squared, just your theta can't have anything attached to it. With these, you just solve them normally, okay? There's no identity. You just solve them. And honestly, all these solving ones are the same. Just with these type of questions where there's two plus functions or there's a weird 2 theta, you're just trying to turn it into one function so you can make it like this and solve it. Okay, so these are some functions. These are for some questions. Try them yourself and then look at my solution. Okay, so for this one, what I can do is isolate always try to isolate, and especially in linear ones, just isolate. Divide by 4, secant x equals negative 2. Okay, so that's 1 over cos. So cos equals negative 1 over 2. Now we have the interval thing again. So we're trying to find it between 0 and pi. So what we do is, where is it negative? CAST. It's positive here, it's negative here. So we're trying to find it in this quadrant. So first of all, we find our reference angle. When is cos negative 1 over 2? Well, that's 60 degrees, or pi over 3, because 6 turns into a 3, remember? Make it 3. Okay. Pi over 3. And then since it's in the second quadrant, it's pi minus that. So it's pi minus pi over 3. And that is going to be 3 pi minus pi, 2 pi over 3. Okay. That's my answer. For the second one. Now, one really important thing with quadratics, never cancel it out. Like right now, I could just cancel this out and it would be sine x equals 0, right? Never do that, because then you miss out on one of the answers. Always bring all your functions to one side, make the other side equal 0, okay? And then factor. It becomes sine x times 1, sine x minus 1. So sine x equals 0 and sine x also equals 1. So again, in this interval, it equals 0 and 1. Well, it equals 0 at 0 degrees and pi degrees, and it equals 1 at pi by 2 in this interval. So those are our answers. Okay, so now it's time for a bit of a challenge question, mostly because the interval is negative. Okay, so try it yourself and then, yeah. Okay, so whenever you see a quadratic, don't get freaked out. You can just say let y equals tan x. Okay, don't use an x because there's already an x here. So okay, I don't know if they'll let you, but yeah, it just becomes a normal quadratic. You factor it out, you get tan x minus 6, tan x plus 1 equals 0, and tan x equals 6 and negative 1. Okay, now after you figured that out, look at your interval. It's between 0 and negative pi over 2. Okay, so if you were to draw your line, like imagine your line, it's something like that. Okay, so if you do your cast rule, because one of our answers is positive, one is negative, right? If you do your cast rule, you can see that in this quadrant, tan has to be negative. So 6 cannot be one of our answers. Okay, so now that we've ruled that off, our other problem is this negative 1 and the negative pi over 2. So what I like to do, I solve it using just normal angles, and then I subtract a 2 pi to find the negative version. So to show you what I mean, tan, I know that tan x equals negative 1. And so our theta r, okay, our reference angle, for if we were to solve it normally, okay, our reference angle is pi over 4, and I'm talking about this normally. So it's going to be, our actual angle is going to be 2 pi minus pi over 4. So it's going to be 8 minus 4, which is 7 pi over 4. Okay, now that I have this angle, to find this angle, I just do minus 2 pi. I know it looks unnecessary because you can just do this using our reference angles already, our negative angle. But trust me, with other angles, what if it was here and then you had to find the negative, right? Just find your normal angle, subtract 2 pi. Okay, this becomes 7 pi minus 8 pi over 4, becomes negative pi over 4, and that's your answer. Okay, so just find your normal angle, subtract 2 pi, go back one rotation. That's your challenge question. Other questions that I have, this is the fifth type of questions when it's two or more functions, and then a weird angle question, and that's gonna be it for today. And so our question is 1 minus cos square equals 3 sin x minus 2. Even with this solving, wherever you see a identity, because it's two different functions, I'm trying to make it one function, the same function. So I can see identity right here, our favorite identity. This becomes sine squared x equals 3 sine x minus 2. Since it's a quadratic, I'm trying to bring everything to one side, so it becomes sine squared x minus 3 sine x minus 2 equals 0. Sorry, my writing's weird, I'm tired. So it's just your normal quadratic. It becomes sine x minus 2 sine x minus 1 equals 0, and it becomes sine x equals 2 and 1. Well, the one thing we know about sine is that it has to be between 0 and 1, okay, unless there's an amplitude. We'll come to that in the next part, so stay tuned. But we know that it can be more than 1 if it's a normal sine. So sine x has to be 1, And where is sine x positive 1? There's only one angle. It's right here. X equals pi by 2. But wait, we're not done. It didn't give us an interval, so we have to assume that it's for all real values of theta. So what do we do? General solution. All we do, take our solution, 2 pi k k e I. Okay, 2 pi k k e I. 2 pi k k e I. Any and every solution. Right now it's only one, but if there were more, plus 2 pi k k e I. Okay, and for the last question, 2 cos 2x plus 1, it's the other variation where it's a weird angle, like a 2 theta, and then you're trying to turn it into one function. Uh, so like I said, this is gonna turn it into two functions, so that's out of the ballpark or whatever it's called. Uh, 1 minus 2 sine square a or 2 cos square a minus 1. You can use either one of those. The sine square one is going to it might confuse you a bit. So I'll just walk you through both of them. The better way is the cos one. I'll show you why. It becomes 2 cos square x minus 1 plus 1 equals 0. 4 cos square x minus, what do you call it? 2 plus 1 equals 0. And it becomes 4 cos square x minus 1 equals 0. And now you can do difference of squares. You get 2 cos x plus 1, 2 cos x minus 1 equals 0. Cos x equals negative 1 over 2 and positive 1 over 2. And then you use, and it's between the interval 0 theta 0x 2 pi. So this is just positive and negative 1 over 2, so it just becomes all the pi over 3's. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Okay. Now, if you were to do it the sine way, it's gonna be the same thing. The only thing that might confuse you is the difference of squares. Okay, because it becomes 2 sine squared x plus 1 equals 0. 2 sine squared x plus 2 plus 1 equals 0. Oh, sorry, 2, so this becomes 4. So it becomes 4 sine squared x plus 3 equals 0. Now you can still do the difference of squares, except instead of, so you'll see what I mean. Your difference of squares will look like this. Sine square x plus root 3 and 2 sine, well, not squared. Oh, this 3 a.m. Cut me some slack. 2 sine x minus root 3. Okay, you see how that works? Because even here, we're just rooting everything to factor it. That's the same thing here, except 3 doesn't have a perfect root. So now sine x is going to be positive root 3 over 2 and then negative root 3 over 2, and it's gonna give you the same answers. Okay, and that's it for trig part 1, for solving trig, algebra trig.